Hello everyone, welcome back. Here's Van Amsen, and today we are going to dive deep into world of dynamic programming, solving daily lead code challenge, counting all possible routes. So this problem not only tests your coding skill, but also provide insight into C++. So without any further ado, let's get started. So to give you an overview, you are given an array of distinct positive integer representing different cities location, and the challenge is to find all possible roads from the starting city to the ending city, considering you have a certain amount of fuel. And you need to bear in mind that moving from one city to another costs fuel, which depend on the absolute difference in their position. So let's implement our code and I will explain it right away. So const int n will be locations size, and const x int mod 10 to a plus 7, and vector of vector long will be dp array fuel plus 1 and vector long n. And for f up to fuel increment, dp of f finish will be 1, so finish will be finish without moving to the always one way. And then we iterate, so int f of fuel, f increment, and for current less than n, and for int next city less than n, we make a next. If next is current, we continue, otherwise we make a transition. And location absolute of current and next will be our fuel consumption, and f less than need, we continue because we cannot reach it. And finally f dp of current and f current plus dp of f minus need, and next modulo is our state transition function. And finally, we return a dp of fuel and start position. So this is an implementation in C++. So let's run it and see if it's working. So hopefully it will work, and I will explain everything right away. So yeah, our implementation works. So for a given array of places, and those are representation of locations, so 2, 3, 6, 8, and 4, and we are given information that start is in the position of index 1 and finish in index 3. So this is start position, this is finish position. So fuel required to travel from city 3 to 8 will consume 5 fuel, and we have 4 different ways to go there. So for example, we can travel through the city 2, 6, 8 or 3, 8, and we have 4 different possibility to do this. So that's why the output is 4. So let's now explain. So now we have constraints, and those are that cities are between 2 and 100, and their locations are distinct integers from 1 to billion, and the fuel would be from 1 to 200, and the total count of roads should be rounded to modulo 10 to the power of 9 plus 7. So we did it here, so initialize the modulo variable, and the problem might seem quite difficult at first, but the key lies in understanding the intuition behind the solution. So the main trick here is to break down the large problem into smaller manageable subproblems, which is the essential of dynamic programming. So let's now transition into our C++ code. So we have our hero, so dp array, where dp ij hold the number of possible roads starting from city I with fuel j. So it's fuel and starting position. So we initialize the values of dp array with 1. If I equals the finish point, is one way to reach the end. If not, we initialize it with 0. So that's why we have initialized a whole table with ones. So now if you look, our main state transition can be given by this equation of dp of fuel and current position that equals to fuel and current position. And additionally, we need the calculation from fuel minus our required need to get to this particular point, and next position, and also we provide a modulo so not to go out of the range. And after we have checked all equations, essentially updating the number of roads at each step of current and next city, considering every possible city we can move from our current city to the next, in line with our fuel consumption. So remember, the order in which we update our DP table measures assigns the fuel for a road depends on roads which with lesser fuel. Well, we need to update our table starting from lower amounts of fuel and move toward higher amounts of fuel then. So that's why our outermost loop in this process is the fuel loop. And yep, that's it. This is how you solve this problem in C++ using dynamic programming. And yep, let's see if it's working for unseen test cases that might be much bigger. So let's run it and hopefully it will pass as well. So yep, it's passed and we beat 8% with respect to memory and 12 with respect to runtime. So all good, and I hope you found this video helpful and find some additional knowledge. And as always, please like the video and consider subscribing for more C++ coding challenge. And as usual, stay motivated, happy coding, see you next time.